Yes, children will continue with the new phenomena. Just consider you have an interface separating two media. This is an interface separating two media. This is the rarer medium and this is the denser medium. So let the refractive index be mu A, and for the denser medium let it be water. So let it be mu W. I place an object in the denser medium, and a ray of light, as we know, when it passes normal to the surface, it goes without any deviation. So it goes straight without any deviation. A ray of light incident at some angle from O gets refracted. Let us name the angle of incidence and refraction as I1 and R1. So a ray of light, when I increase the angle of incidence, the angle of refraction also increases. The angle of refraction also increases. See here, this is I2 and this is R2. When I still increase the angle of incidence, it is seen that the angle of refraction will be 90, or the refracted ray just grazes the surface. This is the refracted ray, it will be 90, it grazes the surface, and this angle of incidence is called as the critical angle. So critical angle is the angle of incidence in the denser medium at which the angle of refraction in the rarer medium is 90. If I still increase the angle of incidence, the ray finally gets reflected back into the same medium. This happens at an angle of incidence greater than the critical angle. So when the angle of incidence exceeds the critical angle, the ray gets reflected back into the same medium. This phenomena of reflection of light into the same medium when it travels from denser to rarer medium at an angle of incidence greater than the critical angle is called as total internal reflection, or in general we write it as TIR, total internal reflection. So once again I repeat, consider a point object in the denser medium, a ray of light normal to the surface goes without any deviation. As I increase the angle of incidence, the angle of refraction also goes on increasing. At a particular angle of incidence called the critical angle, the refracted ray just grazes the surface, or the angle of refraction is 90. As I still increase the angle of incidence, then the light gets reflected back into the same medium. This phenomena of reflection of light into the same medium when light travels from denser to rarer at an angle greater than the critical angle is called total internal reflection. For total internal reflection to take place, the conditions are: number one, light must travel from denser to rarer. Light must travel from denser to rarer. And the second is, angle of incidence must be greater than the critical angle. These are the two conditions for which total internal reflection to take place. Critical angle is the angle of incidence in the denser medium for which the angle of refraction in the rarer medium is 90. Now let us apply Snell's law to the surface. Now since this is air medium and the angle in the rarer medium is R. Similarly, the angle in the denser medium is I. So when I apply Snell's law, I write mu W sine I equal to mu A sine R. But since at the critical angle, when I equal to C, R equal to 90. So I substitute this over here and write mu W sine C equal to mu A sine 90, or mu W by mu A equal to sine 90 by sine C. But sine 90 is equal to 1. Therefore, mu W by mu A equal to 1 by sine C. This can also be written as mu WA, refractive index of the denser medium with respect to the rarer medium, is that is mu WA equal to 1 by sine C, where C is the critical angle. Now this is the third definition for refractive index. The first we saw is Snell's law. The second we saw is real depth by apparent depth. And the third is mu equal to 1 by sine C.